I'm with you. Haley, what's the GCF of 2x cubed minus 72x?
And then Tuesday, you just had shop 6 hours. 9, 10, 11, 12, 1, 2, 6. Okay, let me add this up again. This is 8.
Definitely the
2.5.
Definitely the 2. And if you notice, they each have something else in common. Jason, what do they also have in common? An x, yeah. So for both of these, you gotta be a little careful. It's actually gonna be 2x for each of these. When you take out the 2x, you'll end up with 2x times x squared minus 36. So what's my A and my B gonna be in this case? Yeah, x and 6. So then when we're writing our answer, you just do the opposite. X plus 6 times x minus 6. And then what do we need to make sure we remember to do? Yeah, we gotta bring that 2x to the front. And that's it. So that's a little bit tougher because we had the x there. And if we look at the next one, TJ, what's going to be the GCF of 3x cubed minus 75x? Good 3, and then also, you got it. Anya, when I take the 3x out, what's left inside?
X minus 25.
Good, and don't forget that x is going to be an x squared because we only took 1 away. So it'll be x squared minus 25. And then everybody seems to be doing really well with your A and your B. What are you going to be your A and your B here? The square root of 25 is? What number time? 5 again. So you have x and 5. So then you're going to do the opposites. X plus 5, x minus 5. And Jason, what do we need to put in front of this? Don't forget to bring your 3x over. At home, any other questions or anybody in the classroom for any of the other homework problems?
Others that you want to see test in class.
So please make sure you get this submitted. Okay. Just so we get that in the grade book, should be some easy points for you. We go to our notes. And right after the example 2 we looked at, there was a checkpoint.
So if you want to take out your packet of notes, it's page 34. If you're in the physical packet of notes, page 18, if you're at home.
I think it is 18.
Yep, all right, so page 34 if you're in class, page 18 if you're at home.
My brother's gonna turn 18 this year.
Your brother.
Yeah. He's getting old.
Nothing really wrong with you.
I know. Very unfortunate.
I will never get old.
Never. Never. Okay. So for the first one, we just want to look and see what's your A and what's your B gonna be. Bill, what's your A and your B in this case? X and 6. So what's your answer gonna be? X plus 6, x minus 6. Good. all the examples, even what we're doing today with the perfect squares, these should be faster, easier.
Yeah, think about the problems we did last week. There were like 3 or 4 steps.
Yeah,
These are quick.
quick. Again, we need to look for GCF. Anya, what's the GCF? For number
3.
2? Yeah. So what's left over? Excuse me.
R to the second minus 100.
Perfect. So your A is going to be R and your B is going to be anybody? 10. Good. So now you just write 1 positive, 1 negative. R plus 10, R minus 10. And what can you not forget? Yeah, you want to make sure you bring down that 3. So that's it. All right, look at the next 2. If you notice in this case, is 9 a perfect square? Yeah. So since it is a perfect square, we can find our A and our B. Bill, what's our A going to be in this case? Yeah, the square root of 9 is 3. Square root of m squared is m. The square root of 64 is 8. So you just take 3m plus 8 and 3m minus 8. Okay, let's look at number 4.
It's tricky with that 1/4.
A little tricky, but we're going to figure it out. So you look, does 4 go in 81? Not really, right? So we want to look at the denominator. The denominator is a 4. Is a 4 a perfect square? Yeah. What is the perfect square for 4? Anybody? Anybody? What number times itself gives you 4? Jason? My man. And you notice that that's in the denominator. So look what we're going to do. We're going to put our 2, where are we going to put it, Jason? In the denominator to match up. And then what would go with that 1/2? Yeah. How about your square root of 81? Yeah. So Jason, what is going to be our answer? Half P plus 9. P, oops, minus 9. P or 2 should be. Good. So that one's tricky, but if you just think of it, you could keep the 1 up top, and then you can just look just in the denominator. So really not too bad. A lot easier than it looks. All right, so we're just going to do one more step today, and it's really not that much.
Yeah, so looking at the problems we did yesterday, notice the problems we did yesterday all have 2 terms. So 3r² minus 300, 9m² minus 64. Up above, we had 2r squared minus 18. They all have two terms. So when there's two terms, it's called the difference of perfect squares. Today, instead of dealing with two terms, we're going to look at trinomials, which are three terms. So the factoring is just as easy. It's going to look a little confusing at first, but you're still going to be using those perfect squares. It's just the way your answer is written is slightly different because you're dealing with three terms instead of two. So when we factor it, we have to write our answer slightly differently. So in this little box, this is like the algebra behind what we're doing. For something to be a perfect square, it means the first and the last values are perfect squares. I can take the square root of them, just like yesterday. So I had x squared minus 81. The first and the last were perfect squares. The middle, the most important part about the middle is the sign. If it's a plus, in my parentheses, we're going to write a plus. If it's a minus, in the parentheses, we're going to write a minus. And that's going to be the most important thing to look at. So when we factor this, you're going to take the square root of the first and write that in front, and the square root of the last and write that in the back. And then we're placing parentheses around this and saying the whole thing is squared, meaning there are actually two of the same parentheses. So this really means that I have a plus b and a plus b. Yesterday, I had one plus and one minus because a positive times a negative is how you get a difference of perfect squares. Well, today, they're both going to be the same because a positive times a positive is how I keep a positive value. So every time we factor, our answer today is going to be in parentheses, and that parentheses is going to be squared. If you look at the one underneath, the only difference is that it's a minus sign. So I'm still going to have A, and we're still going to have B, but it's going to be a minus because there's a minus in the problem. So this is called factoring with a pattern. The numbers are special numbers, so I can factor with this special pattern. But we've got to remember that that parenthesis is squared, that there's really two of them, because a positive times a positive means a positive. A negative times a negative is really a positive value. So if you look in the little box, looking right next to it, we have these two examples and then we'll do some more. But it says x squared plus 12x equals 36. You need to pay attention to the first and the last number. The middle number has nothing to do with the factoring. So kind of ignore it, except that it has a plus sign. So plus sign means I have a plus sign in my parentheses. We are still going to say what is A and what is B. A is the first and B is the last. So we're still focusing on A and B. So Bill, if you have x squared, what would your A value be? And if you have 36, what is your B value? 6. So you're still doing that. But now, because it's a trinomial, 3 terms, when we factor it, you're going to have x plus 6, one parenthesis, and that one parenthesis is squared. And again, it's a plus because it's a plus 12x. And that's it.
It saves you the step of finding all the
Yes.
factors of 36. and
So
then
this
finding
is
all
like
the
the
factors.
super shortcut way.
Yeah.
It only works because those numbers are perfect squares. So if you look at the second one, we have x squared minus 6x plus 9. So we're still going to say, what is x? Or what is A? Obviously it's x. And then Emma, what times what makes 9? 3. So a minus sign in front of the 6 is why there's a minus in the parentheses. And then it is just x minus 3, and that's it. But it's squared. So we're gonna see if we can look at these problems underneath. So the most important thing is knowing your perfect squares. What is A, what is B? So factor the perfect square trinomial using the pattern above. So if we look, we have m squared plus 16m plus 64. So let's start with A and B. TJ, what is the A value? So we have m squared, so that means A is going to be, what times what makes m squared? Just m. So here's my A term, and then the B term is 64. So TJ, what times what makes 64? 8. All right, here's how this works. Parentheses squared. What sign goes in the middle of the parentheses, Bill? Why a positive? Because it's a positive 16. And then what goes with that positive? M plus 8. That's it. So always parentheses squared when it's 3 terms, when it's a trinomial. A positive in the problem is a positive in your factor. So if we look at the one next to it, we have 9p squared plus 30p plus 25. So again, we're focused on the first and the last to find A and B. Jason, if we have 9p squared, what would A and B? And then you have 25, so B is 5. So you're gonna have parentheses squared. Is it a plus or minus inside? And again, that's because there's a plus right here. And then what goes in there? Come on. That's it. Like really short factoring. I don't have to go through that whole list of writing all the factors.
You could go through the whole list.
You could, but we're taking 9 times
Yeah.
25.
It'd
Holy
just take you a
cow.
long
It would take you a long time. All right, let's look at letter C. Same thing. I have a trinomial. 16 and 49 are perfect squares. So this works when these numbers are perfect squares. So Emma, what times what makes 16? Again? 4. And then there's an R. And then Emma, what times what makes 49? 7. All right, Emma, we got our parentheses squared. Is it a plus or minus inside? Look, it's a minus. So that middle sign is what determines if it's a plus or a minus. And then what goes in the middle, Emma? 4R minus 7. Questions? So again, that's it. Like there's nothing else to do to factor it. One step factoring. All right, so the last group of problems, we're gonna do these quick extra example 3, and then we're gonna look at just what happens if there's a GCF. So if you look at the next page, we'll quickly factor these. So see, looking at A, B, and C, see if you can quickly factor them. So this is like shortcut factoring. You're focused on the first and the last number in each one of these. So A and B. Peyton, for letter A, can you tell me what A and B are for letter A?
A would be 3.
So it says H squared. I'm looking
Oh,
at
sorry, I was
example-
looking at the other one.
Okay. Nope,
A
you're fine.
would be H. And then B would be, I think 50.
So what times what makes 100? 50 plus 50 makes 100, but what times what makes 100?
50 times 2.
Right? Or 10 times 10. So we want it to be the same number, 10 times 10. So we have 8 and we have 10. So then in the parentheses, h plus sign 10. And again, it's a plus because of the plus. That's it, done. H plus 10. So Bill, looking at letter B, 16p squared, 40p, 25. What do we have there? What's A? And B? And then factor it. Right, so you gotta remember that's squared. That really means there are two of them there. So I still have two parentheses, but they're the same parenthesis. That's why we square it. And then the last one here, Emma, how about 9n squared? So what times what makes 9? And how about 16? And in parentheses, 3n minus 4. So the last little extra piece, we're going to just do these 3 final examples. Factor out a greatest common factor. So if I look at letter A, 5 is not a perfect square. 80 is not a perfect square. They must be perfect squares for this to factor. But we can take out a greatest common factor. Phil, what do you think the greatest common factor would be? 5. So all of the problems here, if it's not a perfect square, there's a greatest common factor that we need to take out. So take out a 5, and Bill, we have u squared minus and then plus 16. So that's our new problem. Now, u squared and 16 are perfect squares because Bill, u squared is just, and 16 is 4. So I would have u minus 4 squared, minus because it's a minus 8u. And then what can't we forget to put in front? The 5, the GCF. So looking at B, GCF. Jason, what do you think 4m squared minus 24m plus 36 have in common? What can we pull out of all of them? A 4. So let's pull out a 4. There's a GCF. And Jason, when you pull out a 4, what do you have left? So looking at M and 9, Jason, the A is, and the B is, nice. M minus 3 squared, and then don't forget the 4, the GCF. So really quick factoring, super quick. The last one on here, 4x squared plus 32x plus 64. GCF first, always the first step of factoring. Is there a GCF? It looks like probably a 4 in this case. So x squared, taking out a 4, 8x, and then 64 divided by 4 is 16. So take out a GCF. And then TJ, what times what makes x squared? And what makes 16? 4. So x plus 4 squared, and then don't forget the GCF. Questions? So those are all the notes we're going to do for today. We'll leave the last group of checkpoint problems as a nice review tomorrow before we start tomorrow's activity. If you want to go to your Google Classroom, we'll look at the perfect squares worksheet for today. And again, this should be short factoring. So it's not long, it's not involved. It just deals with perfect squares. So that first worksheet that is now posted in the stream is our perfect squares worksheet for today. maybe go through and like
Yep.
identify them.
You mean with the trinomials versus binomials? Yeah. Just looking through, we could look at what we did yesterday versus what we did today with the trinomials for the perfect squares. So why don't we just call out what numbers are going to be what we did today? So to have the both plus or both minus.
So this worksheet is like kind of both being mixed together. It's not just what we did today.
Anybody?
So which ones look like the pattern we just did today? The new pattern.
Yell them out. 4, good. What else? 5, 7, 9, 12, 13, good. What else you got? 16 and 17, good. I also want to go through and pick out the ones that have a GCF first, okay? So make sure you're highlighting, making notes of these. In the first row, we are good. The second row, fine. Third row, fine. Fourth row, we got to look at number 11 and 12. Both of these are going to have a GCF. So if you want to mark 11 and 12 as doing GCF first, numbers 13 and 14 have GCFs first. And then numbers 16 and 17. So there's 6 of these 18 that have to do the GCF first. So I want to make sure at home, here in the classroom, please make sure that you have these marked. This will very, very much help you. So I want to do 4 of these problems that are on the screen with you. Bill, why don't you pick one that we'll do together? Numbers 10 through 18. We'll do these ones first. Yeah, let's look at 17. Great. So when we're looking through, to me, the easiest way is you want to think perfect squares. And if we look at the factors of 20, and you can just do this in your head, you think the factors of 20 are 1 and 20, 2 and 10, and then 4 and 5. What number on these factors is a perfect square? 120, 210, 4, 5. Yeah. So we know that 4 is our perfect square, which means what do we want to take out of that 20? A 5. Good. So if we take a 5 out, and Jason, what's that going to leave us with inside? Good. So now we can pick out our A and our B fairly easily. Our A is going to be 2Z. Our B is going to be 7. So this is a new problem we had today. So we know that it's going to be a square. We know that it's going to have a 2Z for your A term and a 7 for your B term. Now he's got to determine it's going to be plus or minus. Yeah, it's going to be minus because we have a negative 28. And then we're just missing one last little thing. What's that? Yeah, bring that 5 down. And that's gonna be your final answer. So great problem to pick, Bill. Great one. Anya, 10 through 18, why don't you pick another one for us to do together?
Can we do 16?
Yeah, of course. So 16 is also gonna have a GCF, and it's the new method we did. Anya, what is the GCF gonna be of 3, 30, and 75?
3.
Yeah, so this one's a little bit easier than 17 we looked at. It's pretty straightforward, just a 3. Anya, what's left when you take a 3 out?
M squared plus 10m plus 25.
Got it. Your A is, and what's your B?
The B is 25.
What a square root of 25 is.
M squared.
So what you're picking here is you're taking the square root
Mm-hmm.
of your last term. So square root of m squared is just an m. The square root of 25 is
Okay.
just a 4. So same as we did yesterday. And now what's new is you're going to have your factors squared. And we just need to determine it's going to be positive m plus 5 or m minus 5. Jason, what is it? Plus, what do we need to bring down? You got it. Very good. TJ, you want to pick one that we'll do together? $13? Absolutely. So 13's another one that's like 17 because there's a lot of factors we could look at in getting that GCF. So if we just make a little tree on the side, factor tree, 124, 212, 3, 8, 4, 6. Bill, which one of these factors has a perfect square in it? 4 is, right? So if 4s are perfect square, then that means we need to take out the 6. Very good. So Bill, what do we get when we take that 6 out? Well, give us the variables as well, please. Good. So what's your A, what's your B? Two, don't forget your variable. 2W, and then the square root of 1 is just 1. So this is that new case we looked at. So we know it's going to be squared or factor. We have our A term, 2W, or B term, which is 1. And we want to see is it 2W plus 1 or 2W minus 1. Good. It's minus, and then don't forget the 6. And that's it. Jason, why don't you pick the last one we'll do together? Okay, 12, good. What is the GCF going to be? Got it. When we take the 2 out, we have 9a squared minus 6a plus 1. Jason, what's your A, what's your B? Got it, 3a and 1. This is the new case, so it's going to be squared. It's going to be plus or minus. Minus, good. Don't forget that's it. That's how quick these should start being for you. When you're looking below, 15. These would be really quick. These are perfect squares. 5x, 13. 5x plus 13, 5x minus 13.
Yeah, two parentheses. The plus, all the minus, so it's different.
So these should start getting really quick for you. So we did the hardest ones. The rest should not take you too long. So good work.
Have a great day.